Hello, everyone. My name is Emily Ikuda, and I'm Percona's Digital Marketing Manager. We'll begin in just a moment. But first, I'd like to conduct a bit of housekeeping. First, please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me. Okay, good. I see some hands raised. Thank you for that. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer any questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours along with the slides. The floor is yours, Daniel.
All right.
Oh, wait, sorry, hold on.
Okay.
Let me introduce you. I would like to thank you for attending today's webinar, Introduction to MySQL SYS Schema, presented by Percona's consultant Daniel Guzman Burgos. With that said, I will now turn the floor to Daniel.
Okay. Thank you, Emily. Hi everyone. Welcome to the Introduction to MySQL SYS Schema webinar. Like Emily said, my name is Daniel Guzman Burgos. I'm consultant at Percona. So let's start with the agenda of the webinar. Okay, so basically it's just these items. We're gonna do introduction to SYS schema, small review of the performance schema, the installation, overview of objects that make SYS schema, and a couple of examples. So let's start with the introduction to SYS schema. Okay, the SYS schema originally was the PS Helper project. It's a collection of views, functions, and procedures to help MySQL DBAs to get insight into the database usage. The SYS schema implements many of the common day-to-day DBA and developers debugging and tuning use case. And the SYS schema layers on top of the sometimes very, very complex queries from performance schema into a package set of easy to use views. The SYS schema is a project started and maintained by Mark Lead, which right now he's an Oracle engineer. And you can read more about the project and Mark himself at his webpage, so check it out if you have some time and curiosity. The SYS schema is the solution for the usability problem that the performance schema had. So what usability problem, you might ask? Well, let's take a small journey to the performance schema to be aware of that usability problem that sometimes scare us to use the performance schema. So the performance schema is the name for both the storage engine and the database itself. It's implemented since MySQL 5.5 series and records runtime statistics from all the MySQL database. The idea behind performance schema is to provide access to useful information about server execution while having minimal impact on server performance. That's the key, minimal impact over the performance. Let's remember that performance schema it's platform independent. It's not like tools like IOStat or VMstat, which depends on the platforms, and you have different parameters for doing the same stuff between Linux or BSD or OS X, on different platforms, different ways to do things. Monitor server events, statements, stage, waits, etc. Focus on low overhead and pretty fast collections. The times measured in picoseconds. That's high resolution. Operates in fixed memory and have portrait event IDs. Before performance schema, the tools that we as DBAs had available to perform analysis were status variables, session, and global. The show DB status, which is amazing, but it requires some time to understand. Show profiles and the MySQL slow query log that you can use with in conjunction with the Percona query digest or stuff like that, or another tools. Now we were gifted with the performance schema tables. We can still use, and I personally use the other tools and information sources to perform analysis, but we can complement it with the performance schema tables. However, the thing with performance schema is that it can be so intimidating because there's too much info and too much table. There are 52 tables to query. There are 31 configuration variables, instrumentation that you have to set up, to enable. There are a lot of things that you have to do in order to have a performance schema to collect data, and not only to collect, but to analyze that data. So this is where SYS Schema comes to the rescue, and this is the usability problem that SYS Schema try to solve. So now let's move to the installation of SYS Schema. Installation is pretty easy. The first step is to get a copy of the SYS Schema files that it's on GitHub on a repo. You can clone the Git repo with git clone. If you don't have Git or want to use something else, you just can download all the files on a zip file and unzip it. It's practically the same to get the files. Now, for actually install the SYS schema, go to the word at the directory where you download the files and just execute the. In this case, we're gonna install it for 5.6 series. Just run the sys_56.SQL file, and that's it. You don't have to do anything else. It's that easy. A note about for 5.7 series, starting from MySQL 5.7.7, SYS Schema comes included by default. So when you start your MySQL 5.7 server for the first time with any method, the SYS Schema it's added beside other information schema, performance schema. It comes by default. You don't have to do anything else. Just initialize your database as you normally do, and that's it for 5.7, 7 and upward. Now, after the import, you have a new SYS schema. If you go and do show databases, you can saw it. And it will come with very descriptive table names. So from the beginning, you can do something like know what tables are using the InnoDB buffer memory. It's just as simple as do a select to InnoDB buffer stats by table view, and that's it. So this is an example for a recently started MySQL instance. There's nothing much on it. What about after we create a huge table? Huge in this case because this instance that I use for get the examples is use a very small buffer pool. And after I create with SysBench a table with 1 million rows, basically all the buffer pool is devoted to this new table. So this is pretty cool. And it'd be pretty easy to find out what's going on inside on the buffer pool in this case. But this this magic it's backed by not so simple query. So what's behind that view is this query that certainly is not something that we will sit and write every day, isn't it? So this by looking what is inside this view, we can see the value of having a SYS schema available for usage. Even this is not one of the complex views, so it's pretty cool too. Now, let's talk about the let's do an overview of objects. Okay, on SYS schema context, objects are just the collection of views, procedures, and functions, and also one table with a couple of triggers. That's it. Those are the objects that make part of SYS schema. So let's go to an overview of all the objects. First, we have procedures. You can see it easily after you install it. Procedures for SYS schema are mostly config helpers. They are for procedures to check and configure performance schema. There's also a couple to help analysis on a different moment. For example, PS setup save. You can save configuration that you made by yourself for a specific issue that you are analyzing, and save it for use it later, where you can use the PS setup reload save it, and that easy you will have the same configuration, like the same environment that you were using for analysis, that you configure prior or in another moment. So next we have the functions. Functions are more user mostly inside the views. For example, there are functions to make output human readable, like format time or format bytes. Format time properly, format bytes properly, extract object names, DOM and trace tag, check instrument actors along all over the performance schema to see if there is an instrument that it's enabled or consumer that is enabled that I need for certain or a specific view or specific info that I want to see. Next, we have the table that is the only table that SYS schema creates. Basically, it's for store configuration options, and it's for persist configuration across upgrades. There are a couple of triggers that works over the sysconfig table that speak by itself. And there are the views. There are 45 amazing views, so this requires to go slowly, and so let's go slowly with these views. The views are not only for performance schema, there are also views that use the information schema too. You have available both views for native, like with human readable output, but also you have the views with raw data. The difference is that it's the same name, but the prefix with X and the dollar sign, that's all the raw data. And also you can add your own views. SYS schema is not a closed work. If you see that there is a view that you can do better, or there is a view that is missing for a particular purpose, you just can create it and add it to your particular SYS schema configuration, and also you can contribute to the project. That's the beauty of open source. So don't be afraid to do your own views. So let's start with the first group of views. This is the user host summary views. It's just high-level user and host overviews. It's breakdown by I/O usage, by stages. Stages, I mean all the steps that query pass in order to return a record set, opening tables, sending data, optimizer, stuff like that. Also, there's a breakdown for statement details, and it's pretty useful. So the names are very descriptive, so it's just a matter of try them and go do and select and use it and see what's the output for your particular database. We also have the I/O summary views. This is for I/O by current threads. It has global summaries by file and class, and aggregating by bytes or latency. Pretty useful too for analysis on the file level, see where's your time spent mostly, or stuff like that, or where are your bytes going on your disk side, or stuff like that. Okay, now we have the schema analysis view. These are for mostly to get table usage statistic and index usage statistics. With this, you can easily find out if you have indexes that are not being used, for example, or you have tables with a lot of usage and maybe hot tables and that are being used with the best way. For example, the schema table with full table scan, it's great, it's awesome to find out if you are missing an index or what's going on with tables that are being accessed with full table scans and probably not being used for in the sheet's best performance. And the same is for the unused indexes. So I think that this is one of the most uses on a daily basis for after deploys, after new queries, new tables. This is pretty useful. Now we have the weight analysis views. It's weight details per user, per host, and globally. Also pretty good to know where you the time spending by waiting stuff or logs or stuff like that. It's for a more in-depth detail debugging, where it's also pretty useful. Okay, now statement analysis views. With these views, you can find statement by the ones that raise errors, the ones that the statements that use full table scans, the ones that are creating temporary tables, which is pretty useful. You can also find this data with, for example, the enhancement that Percona server has on the slow log. But this is just another way. It can be faster, or it can be just for a specific table or a specific timing moment, or who knows, you can use this for create your own alert service monitoring for Negios to let you know that when there are queries that are hitting temporary tables on disk on a very high rate or stuff like that. Well, you can also find out a statement with close sorting, or the ones with latency in the 95 percentile. So you can start with these queries that are mostly the slowest one, and trying to do so and rewrite and increase performance. Okay, and finally, the miscellaneous views. In this case, is only process list. This is a process list output that has no mutex contention and also have live statistics for queries. For more detail and source code of all these views, you can check the repo for SYS Schema. There's more detailed explanation on all the views, on the fields that the views resolve and return. Also, you can see what's the query behind the view. Also, mostly involve the use of functions for formatting and stuff like that. So if you're curious and want to go on detail with not only the views but the procedures and the functions, you just go and check it out the repo for the SYS schema. Okay, so let's see some examples. Okay, this first example is the output of the user summary by statement type view, which it's a view that is based on the performance schema table events statement summary by user by event name. Also use the format time function. Okay, this view, it's a great view to have an insight of what's going on inside your database in terms of events. In this case, the top one is by far the inserts, which is expected, as this database was only used by Sysbench to create the table, the 1 million rows table. So you can see the calls, the total latency, which in this case is tab n is 4 minutes. The max latency of the single insert, the slowest insert was almost 2 seconds. Log latency, rows data, in this case, rows affected, which includes the rows inserted. There are also another ones called procedures that are from the SYS schema itself, selects, create views, etc., etc. this is a lot of info to know in a general overview what's going on inside your database. If you suspect of, for example, set option when it's pretty high, it could be an issue with how your application is connecting and reusing the connection to the database. Sometimes you set some things at connection, and if this is high, could be that you're not reusing well the connection that the app is creating. Also, you can see things like errors. In this case, that treating errors doesn't say what kind of errors, but it's just a hint to start to looking inside to find out what's going on. The quit and the kill also, that there's a huge difference if you saw too much kills and you as a DBA are not the responsible for those kills, so it's a good hint to start looking for access that people shouldn't have, or grants that users shouldn't have, and stuff like that. So it's pretty useful. So like I say, this view is based on a performance schema table. The events statement summary by user by event name table. If you go to that table definition for that performance schema table, you can see mostly the same data, but it's more raw than the raw view. Okay, so it doesn't have like some kind of aggregation, or the format it's difficult to understand. Basically, it's always an issue of usability. So this is a great start to know what's going on inside your database in terms of statements users. Okay, this is another example. This is the IO global by file by latency view, also based on another performance schema table, which is file summary by instance. And not only use the function format time, but also the function format path for the file field. Okay, this view shows the top global IO consumers by latency by file. So basically, it's the most used files over the time, not over size, but time. So in this case, the redo logs, the IB log files, then is the IBD for SB test1. That's the name of the table that I created with sysbench. And then the IB data itself is not used. It's not that used because several things. It's just we're using file per table. So the data is on the IBD file, and on the IB data, the main table space, we're just gonna write some data dictionary info and the undo logs. Then is the trigger file for the sysconfig table and some other files, but basically you can. It's another way to see where is the time spent on the database itself, but looking by the file system. This is also useful for find out if you're using too much temp tables on this. For example, it will show in there. So it's just a matter of get use of these views, use it on a constant basis, on a workload that you know that, which is the workload that you, the traffic that your application, that you know how are the little details of the traffic. So you might expect some tables to be the most used, but also you can see that if there is a problem with uh, a trigger or a temp file, or it's not flushing enough, or any kind of issue. So it's the IO global by latency, based on the file summary by instance performance schema table. Again, you can do as an exercise, go to the performance schema database and check out what file summary by instance table looks like. It probably have more fields than the ones shown by SYS Schema, but this particular view, I'm sorry, but it's more useful to look at the data through this view. Okay, so these are more examples. These examples use three views: the schema table statistics, the schema index statistics, and the schema tables with full table scans. These three views use two performance schema tables: table IO weight summary by table and table IO weight summary by index usage. These views are the result of a little more complex queries that involve a bunch of joins. I think there's left joins, so it's useful data with the same easy to access, but backend by a more complex query. So with these views, what's the good for this? Okay, if you want to know what the most used tables, you have it. You want to know what are the hot indexes, the most used, you also have it. Also, you wonder if you have tables that are being accessed by full table scans, well, you have it too. It's great info. The other way to have this info without using performance schema or SYS schema, it's, for example, using gathering all the traffic with a slow log file with long query time 0, then collect data for a while, then process that slow log with one of the Percona toolkit tools, like for example the index usage tool or the usage tables. That again, it's useful, and you can do it. You can still do that for and analyze a range of time and just have that data of that range of time and perform different analysis over that data again. But there's this alternative also, which is the easy use of the views, which are schema table statistics, schema index statistics, and schema table with full table scans. Again, these are the performance schema tables that I use. Remember what we say when we were looking at the objects overview of the views, the statement analysis view. There are more to use. The statement with errors or warnings view, the runtimes in 95th percentile, the sorting, and the statement with temp tables. That's a cool one too. So this is just a small example of what you can do with the statement analysis views. Okay, now we have the statement analysis view based on the events statement summary by digest performance schema table. Okay, this table, the performance schema table, record statement events summarized by schema and digest. The digest, like you can see at the bottom, it's like a unique ID that you can use later for a more in-depth analysis of the query with one of the store procedures that comes with the SYS Schema, which I think is it's PS trace statement digest, I believe, that you can just put that digest and you can see much more in detail data from that query. But in this case, it's the view aims to emulate the behavior that you can find by using tools like PT Query Digest or the MySQL Enterprise Monitor Query Analysis. It's just a list of normalized statements view with aggregated statistics ordered by the total execution time per normalized statement. Okay, so if you are familiar with PT Query Digest, you can do some comparisons. For example, when we say normalized statement is the same PT fingerprint that the PT Query Digest uses. The fingerprint is, for example, in this case, the insert into the SBTest1 table with the fields that they use and values, which are generic value. It's not that a specific number, because the aggregation will be useless. We'll have a lot of queries that are similar but with different values. So it's mostly the same as the fingerprint that PT Query Digest uses. Okay, so you can find here a lot of useful data like the execute count, that it will be the calls on the Query Digest. This type of query didn't raise any error or warnings, which is great. The total latency of or how much time the database spent attending this request, resolving this kind of query, which was the slowest query, how long it takes. This is the same info as you can see on the first example, which was the user summary by statement type. As you can see, the max latency for the insert, it's 1.96 seconds. This is it's the same for here, which we're talking about the same statement, but this is in a form of a list. Row info, percent, and average, examined, affected, etc. info about temporary tables. If you can see if this kind of query uses temporary tables, and in case it does, you can see it also use temporary disk tables. Sort data, digest, and also some data of first seen and last seen. This is helpful for example, after a deploy of new code, uh, if, if the query start to be used and it should be, you can see all the data in this view, the statement analysis view, which is based on again a performance schema table, the event statement summary by digest. And it's just again another way to analyze what's going on inside the database. Okay, now we have the final example is with the process list view. Like we said earlier, this intends to be a detailed and non-blocking process list to replace the classic show full process list or select information schema dot process list. It is based on the performance schema tables threads, events waits current, and events statements current. So in this case, for this example, this view has more fields, but I just put the most I can put so the screen can be human readable. So in this case, there is the thread ID, the connection ID, user, database, command, state, time, current statement, log latency, temporary tables, temporary disk table, and if it does a full scan, again, this view has more fields on the output, so it's which is cool because it's a process with more data and useful data. Again, no blocking. So also by checking the process list with this view, you can also see that in the user column that the internal threads or internal stuff it's also showed. For example, the InnoDB IO handler thread, the server monitor thread, server error monitor thread, master thread, push thread, the LRU manager for the buffer pool, the page cleaner thread, and the signal thread that it's upper from the storage engine. This is from the MySQL itself. So more info. When I run this, the only query that was running was the view itself. So it's the only thing that it shows. Shows how the log latency that it used two temporary tables, and one of those temporary tables goes to disk. And you do also a full scan. It's not like if it was a regular query, I would definitely jump right now to try to optimize this query because full scan, temporary disk tables, but it's a view, so kind of expected. Okay, so like I said, the view process list is based on 3 Percona schema tables. It doesn't use the information schema process list table. It gets the same data through a different path. it uses threads. Events waits current and events statement current. The query behind this view, it's awesome. So it's something that I will encourage you to look at and see how put in perspective things like the value of the SYS schema, like the value of performance schema, but also the lack of usability, and that explain why there is no much production databases out in the wild that don't even have enabled the performance schema, but also there are ones that are enabled but rarely saw the data. It's scary, but with SYS schema, there's like no excuse. Like it's much simpler job to do. Also, after you're familiar with SYS schema as an introduction or as a first thing to use, you can go beyond. You can use the store procedures for more in-depth analysis of queries, of weights, of bottleneck, debug at the file level, at the thread level, at the IO level. So it's just a matter of get used to it. And it's gonna be something that is gonna it will compare on a day-to-day tool to use, especially now with 5.7 that it's SYS schema came by default, so it's more easier to have access to this data. It's already in there. Okay, so that's it. We can see if there's any questions. I'll try to answer.
Okay, Emily is now going to read the questions. Okay, well, this is Elisa. I work with Emily, and you know me from all the other webinars that we've done in the past. This is Emily's first webinar, so please forgive the technical difficulties. I'm going to go ahead and start reading the questions. And Emily, when you are able to join us, go ahead and jump in.
Okay. I'm in.
Oh, okay. I'll turn the floor back over to Emily. Nice to see you all. Go ahead, Em.
Thanks. Okay, so our first question is, can I have the performance schema enabled in 5.6 and then install the SYS schema, or they are one and the same?
What was the last part, or what?
Or they are one and the same.
Okay, well, for my case, when preparing this, I use 5.6 that was having already the performance schema enabled. I just install it, and that's it. The only requirement is like you have the performance schema enabled at the startup. So if you don't have it, you can just put on the CNF file the performance schema enabled, and that's it. That's like the only requirement. But the rest, the instrumentation, setup, and the other things that this schema need to enable for usage, it's done by the tool itself.
Okay. Next question. The installation of SYS schema on primary database will be replicated to the slaves?
No, the installation. If you see the source code, there are a couple of SQL files before installation and after installation that disable the replication. Actually, disable right into the bin log by setting SQL log bin equals 0, and at the end it will enable that game for the session. So now.
Okay, great. And so here's our next question. Can MySQL save the slow running query in any table?
Can MySQL save the slow query on a table? Well, yeah, there's an option where you can set where do you want to put the slow query. If one of the options is table and the other one is file. So yeah, that's for example on RDS on Amazon. I think by default it's on table. I think that's the only way. So yeah, you can save it on a table.
Okay, great. So this is our next question, and I apologize if I get this a little bit wrong. How to see the query execution date and time from events underscore statements underscore current slash history views in performance schema, or looking for execution date and time, or in the history type views looking for execution date and time.
The event statement summary by digest, it is, Emily?
It's how to see the query execution date and time from events, statements, current, or history.
On the performance schema, I'm not following, but I think that...
If not, we can follow that up in the blog post.
Yeah, I will need to check it out, but I think that's recorded by the instrumentals of the performance schema itself on the table. But I will put a proper answer on the blog post. So.
Okay. We have another question. When the SYS schema views show certain stats for the queries, is there an execution time range for queries under evaluation, or is it like all the queries executed till date?
It's all queries executed, but there is a store procedure that you can define a range of time to be analyzed. That could be I can explain that too later on a blog post, but you can define that with a store procedure.
Okay, and we'll do one more question, and then any questions that we weren't able to address will be followed up in a blog post following this webinar. So with that, our last question is, I want to write the automated script to rebuild table or index. How to determine which tables or indexes are needed to rebuild because of high fragmentation ratio?
Well, that's not in the scope of the SYS schema, but by fragmentation on the B tree or in the file, that's different. Fragmentation on the B tree, it's something that can be addressed by rebuilding the table with an alter. In this case, in alter and doing an engine equals CNODB. But in the file, I know there's a patch on Facebook that can avoid that, but I will have to look at and you will have to compile the whole database with that patch. I can check it out and come back to you later.
Okay, great. Well, I do want to thank everybody for attending, today's webinar, and thank you, Daniel, for presenting today. With that, that does conclude the end of the webinar.